Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's class. We are going to talk about functions today. We've already talked about functions, but we're going to get a little bit deeper into functions and their graphs today. We already know that functions are represented by f of x, okay? Please remember that f of x and y are exactly the same thing. Just a different way to write it. The f of x is interpreted as function f, where x is the independent variable. Okay? Let's be very careful. Just really quickly, a brief review. Let's say I have h of y equals whatever, 2y minus 4. Okay? This just represents, hey, reader, this is function h. This is the name of the function with independent variable y. So if I tell you find h of negative 2, what am I replacing the independent variable with? So I literally plug that bad boy in. So that's going to be negative 8. Okay, well, the ones I like are stuff like this. What am I replacing my y with in this particular case? So this is going to be 2 times x plus 4 minus 4. So that's 2x plus 8 minus 4. So that would be 2x plus 4 for that particular function. I am replacing the independent with what I'm given. Does that make sense? Okay. Remember also that in order to find the domain of a function, when only given an equation, you must find all real number x values that make f of x a real number. Please try to remember, my friends, that whenever you have a 0 in the denominator, that's called undefined. So when we're graphing and working with complex functions and equations, you have to be able to identify those values. Now, we've already done some of that. If you guys remember when we were doing our rationals last chapter, let's say that after you added something or multiplied something, you came to the rational function x plus 4. Remember that I told you guys there's a restriction to x, right? X plus 4 cannot equal 0, so x cannot equal negative 4. You guys remember that, right? I was already preparing you for this part right here, finding the domain of a function when you're given an equation, okay? So it is very easy to find the domain of a function when given an equation if you remember, please remember, the domain of any function will always be all real numbers, which of course is denoted, because we know how to do interval notation, except there are 3 exceptions, my friends. All right? Whenever x, or the independent variable of that particular function, appears in the denominator, you must set that denominator to not equal 0. Because that denominator cannot equal 0. If it equals 0, it's undefined. You're done. You're out of gas. The domain will equal all the real numbers except for the values that make the function undefined. So let's take a look at this. Please don't worry about the numerator. The numerator can be as nasty as it wants. We'll talk about the restriction for the numerator. The numerator doesn't matter unless it's in a square root. Then there's a rule for it. But if the numerator is not in a square root, don't even sweat it, I promise. What we're going to focus in on are the values that are going to make this undefined, because that cannot be part of our domain. So in this case, my denominator is equal. I know that x cannot equal 0. So my domain, several ways to write this. The correct way is interval notation, okay? And it's basically going to be negative infinity to 0. You know what? Let me give myself some more space. It's going to be from negative infinity to 0 in union with 0 to positive infinity. Now, let me show you what I'm picturing in my brain so that you can see this easily. And until you start picturing it, you can write this down. If I have a number line, here's my 0. I know that 0 cannot be the solution, correct? But can't everything to the left of 0 be a solution? And can't everything to the right of 0 be a solution? So isn't it from my smallest value, negative infinity, to 0 with a parenthesis because 0 is not included, in union with from 0 to positive infinity? Does that help you guys see that? Okay? Sometimes people ask me, Mr. Morrow, how else can you write this? You can write the domain as follows for this particular case. You could write it as x does not equal 0. That lets the reader know, hey, it's anything except for 0. You could also write it as x is greater than or equal to 0 and also less than or equal to 0. That's Mickey Mouse way, though. And then the real way, the way you're going to see professionals do it, from negative infinity to 0 in union with 0 to positive infinity. I see a hand up. Yes, sir. Thank you. I put less than or equal to 0 because I was testing you. And you win. No, I'm kidding. Thank you so much for paying attention. I should pay attention. It's greater than or less than. Great job, son. Nice. Does that make sense, boys? Sorry for that. I was a little stupid on my part. Does that make sense? All right. Let's look at number. May I erase this? Because it's getting a little too jumbled. Thank you. All right. So here, we don't worry about that because it's not in a square root, but we definitely worry about this. So I know that x minus 5 cannot equal 0. So x cannot equal 0. So my x cannot equal 5. So my domain is, again, if you have to picture it, picture it. Here's my 0, here's my 5. It cannot equal 5. So it's everything to the left of it, everything to the right of it. So I go from my smallest value, negative infinity, to my largest value, 5, in union with my smallest value, 5, to my largest value, positive infinity. Why do I put that U? Because it's a unification of both of these sets of answers. It can be anything to the left of 5 or anything to the right of 5, but it cannot be 5. Does that make sense, guys? You promise? I could go crazy on you, too. I could do something like this, 2x over x squared, I'm just going to make one up that's nice and easy, plus 3. Thank you, you have to factor. Thank you, 3 and 1. So now, check this one out though, okay? Actually, let me just go ahead and do this so we can see it properly. Hello? Hello? Why is that not there? You go. A little delay there. Relax, relax. All right. Come on, man. Who am I? Okay. So what do we have here? We have that x plus 3 cannot equal 0, and x minus a plus 1 cannot equal 0. So x cannot equal negative 3 or negative 1. Picture it. Do yourself a favor. Check this one out, because this one's a cool one. It's everything to the left of negative 3, everything in between negative 3 and 1, and everything to the right of negative 1. You guys see that? Promise? Let's see how to write this interval notation. How do we do this left side? My domain. Negative infinity to negative 3. Heck yeah. In union with? No. Negative 3 to comma negative 1, because that's included as well. And then in union with? Yes. Yes. Excellent. I see some of you guys looking a little bit scared here. Talk to me. That's what I do for a living. Let's go. Talk to me. You guys got this? All right. Cool beans. Thank you. Huh? Well, I just asked you if you I just asked you if you got it. So we'll try again. So everyone got it? Okay. Great. Thank you. Okay. Now, Number 2, my second exception. Remember, it's always going to be all real numbers. Always. Except, 1, if there's a variable in the denominator, you got to set that not equal to 0. 2, if whenever x or the independent variable of that particular function appears inside of a square root in the numerator, you must set the inside of the square root to greater than or equal to 0. Why do you think you'd have to set the inside of a square root to greater than or equal to 0? Think about it, guys. What's the square root of negative 4? Really? 2? 2 times 2 is 4, not negative 4. Really? Negative 2? Negative 2 times negative 2 is 4, not negative 4. Yeah, this is what's called no real solutions. This is going to come out, and we'll learn this in about a chapter or two. This is going to come out to be plus or minus 2i. It's an imaginary number. So whenever you have a negative inside of a square root, it's not a real number. So remember what we're looking for. We're looking for the real numbers that make this work. So we have to set the inside of the square root to greater than or equal to 0. I can have it as 0 because the square root of 0 is 0. Cool beans. But the square root of negative 1 is not 1, and it's not negative 1. It's 1i. It's imaginary. So we cannot have square roots that are negative. So, easy peasy. Let's check it out. For a, inside of the square root is x plus 3. So set the inside of the x plus 3 to greater than or equal to 0. X must be greater than or equal to negative 3. So my domain, you could do x is greater than or equal to negative 3, or big boy status, or big girl status, out for those of you viewing out in the internet world. Negative infinity, no, wrong. Bracket, negative 3 to positive infinity. If you can't picture it, graph it. Okay, yes sir. No. The domain is all real numbers, unless there's a variable in the denominator. You set that to not equal 0. Number 2, unless there's a square root in the numerator. And in that case, you set it to greater than or equal to 0. So my domain here, okay, it's negative 3, greater than or equal to 0, bracket to the right. Inequality, interval notation. Now, in B, pay attention. I have 2 restrictions here, don't I? I have this bad boy down here, which cannot be 0, so I must set 2x not equal to 0. And I have this x minus 5 inside of a square root, so I must set x minus 5 to greater than or equal to 0. Do you guys see this? So I know for sure that x cannot equal 0, and I know for sure that x must be greater than or equal to 5. So in this case, this is quite particular, okay? Because it has to be greater than 5. So if I look at this on a number line, I know it can't be 0, but it's got to be greater than or equal to 5. So do any of these values over here, are they even valid? They were made invalid because of this. So my domain, x has to be greater than or equal to 5, or in other words, bracket 5 to positive infinity. Have you guys seen this? I need this. I don't think this is hard, but this is the toughest part that we've done so far for chapter 8. I need this solid. Sir. Okay, well, I have 2 restrictions. X is not equal to 0. Bless you. It's not equal to 0. But all of my x's have to be greater than or equal to 5. So all of the x's to the left of 5 are not valid because x must be greater than or equal to 5. Does that make sense? You sure? Okay, awesome. Awesome, awesome. Okay? Now, let's continue here. Okay, number 3. When x, or the independent variable of that particular function, appears inside of the square root in the denominator, you must set the inside of the square root to greater than 0. Not greater than or equal to 0, but greater than 0. The domain will equal all real numbers except for the values that make the function undefined. So let's check this out. Do I have to worry about this up here? No, because it's not in a square root. But I do have to worry about this. This cannot be negative and it cannot be 0. So I must set that x plus 3 to greater than 0. X must be greater than negative 3. My domain is x is greater than negative 3, or in interval notation, negative infinity. No, it's greater than negative 3. Negative 3, comma, positive infinity. Why would I have another restriction? This is not in a square root. That is not a restriction. If it's not in a square root, I already said, do you have to worry about the numerator? No. Now, B, how many restrictions am I going to have here? 2. When I have a square root in the numerator, I must set that to greater than or equal to 0. When I have a square root in the denominator, I must set that to just greater than 0. I cannot have 0 in the denominator. So I'm going to have that x is greater than or equal to 7. Please remember that this can factor. So that's x plus 3, x minus 3, okay? Okay, we have a little bit of a problem. Oh, no, it's a great tour. Okay. So this is, x is going to be greater than negative 3, and x is going to be, I'm sorry, x is going to be less than negative 3 and greater than positive 3. Let me explain that for a second. On a number line here, you have the following. You have a 3, you have a negative 3, okay? But do you see how this is a greater than? How it's greater? Always go greater. So you take the negative 3 and you take the 3, okay? When it's greater, we want to be shading on the outside of the graph. So it's going to be shaded to the right and it's going to be shaded to the left. Hence, x is less than negative 3 or x is greater than 3. And you also have the restriction of x is greater than or equal to negative 7. So in my number line here, I got a negative 3 that I have a restriction, I have a 3 that I have a restriction, and I have a 7 that has a restriction. Which restriction supersedes everything? Greater than or equal to 7, exactly. Since it has to be greater than or equal to 7, all of this becomes invalid. So my domain would be x is greater than or equal to 7, or bracket 7 to positive infinity. And those are my 3 restrictions. Yes, sir? Can you simplify x squared minus 9? X squared minus 9 is not x minus 3. It's a difference of squares. No, you cannot square that because you're talking about a polynomial. This does not square out to be x minus 3. I never taught you that. If you know, why would you ask me? If you know, why would you ask me? I love that out there in the world. I love how my boys say to me, oh, I know that, but I'm just asking just to annoy you. That factors out into that. You cannot pull anything out because you don't have two pairs. Okay, now, actually, before we do this, let me do one little brief synopsis. I want you to find the domain of each of these. 1, if I tell you f of x equals 3x squared minus 2x plus 5, what's my domain? Immediately, you should be able to tell me all real numbers, Morrow. Are there x's in the denominator? Are there x's in the square root in the numerator? Are there x's in the square root in the denominator? Didn't I say that domain is all real numbers for any function except for 3 restrictions? Do you see any other restrictions there? That's all real numbers. What's my domain? Do I have restrictions here? My restriction is my denominator cannot equal 0. So x minus 4 cannot equal 0. So x cannot equal 4. My domain, negative infinity to 4 in union with 4 to positive infinity. Do you see this? Are you sure, my friends? Let's look at another one. What if I tell you find the domain of no. Do I have any restrictions? I have a square root in the numerator. When I have a square root in the numerator, I must keep that greater than or equal to 0, because a negative inside of a square root will be imaginary. So I add 3 to both sides, divide by 2. So x is greater than or equal to 3 halves. So that means bracket 3 halves to the right. Find the domain of what do I do there? That's right. This is my restriction. So I have a square root in the denominator, so I must set x plus 3 greater than 0. So x must be greater than negative 3. My domain, bracket, negative 3 to positive infinity. Please, my brothers, talk to me. It's not a bracket. Thank you, son. It's a parenthesis. Thank you, brother. Talk to me, boys. Guys, talk to me, please. Sir. Okay, why did this overrule the other ones? Because x has to be greater than or equal to 7. Look, think about it. If it's greater than or equal to 7, am I ever going to see 3 or negative 3? So I don't have to worry about that. If I go x is greater than 7, everything works. Does that make sense, kid? Thank you, my brother. Yes, sir.
I still, because there's 3 different ones, how come it can't be x is less than negative 3?
It can't be x is less than negative 3, because if x is less than negative 3, then this top part will become negative. And then it's imaginary. Above 7 makes this positive, and above 7 makes this positive and not 0. So that satisfied everything. Those are great questions. Thank you, son. Does that make sense, boys? All right, now the easy part. A lot of memorizing, but you got to do it. Okay, I showed you this before, but now I'm going to show you the library of functions with domain and range. Okay? You have what's called an identity function. An identity function is when the slope is 1 and the y-intercept is 0. My domain, look at what's happening here. Am I not going further and further to the right little by little? Am I not going further and further to the left little by little? So domain, all real numbers. Am I not going up forever? Am I not going down forever? So in this case, range, all real numbers. Remember how I told you that every function is all real numbers unless I have restrictions? What's the domain here? All real numbers. You with me? Because what's the function? F of x equals x. Do I have any restrictions there? So it's all real numbers. Quadratics. Do I have any restrictions? My domain is going to be all real numbers, but why? Because I'm going further and further to the right, and I'm going further and further to the left, so everything is being encompassed on my x side. My range, my lowest level is 0. From 0, I can only go up. So my range is 0 to positive infinity. A cube function. That's when f of x equals x cubed. Do I have any restrictions? All real numbers is my domain. Why? Because little by little I'm going to the right forever. Little by little I'm going further to the left forever. My range is all real numbers. Why? Because from 0 I go up, and from 0 I go down. So it's all real numbers. You with me? Okay. Rational functions. We just did rationals. Wait a second. Look at the function here. Do I have a restriction? What can x not be? Does it ever touch this 0 line? See? That's the beauty of knowing your restrictions. So my domain, negative infinity to 0, because I go from 0, I can go to the left, and from 0, I can go to the right. So in union with 0 to positive infinity. My range, though, my range is wrong. This is a wrong range here. This should be the same as the domain. And I'll prove it to you. I never touch this 0 line, or I never touch this 0 line, right? So my y can go from 0 up or from 0 down, but never the 0 itself. So my domain and range are both negative infinity to 0, union 0 to positive infinity. Square root function. Uh-oh, wait a second. Do I have a restriction? Yes. In this case, I got to set x is greater than 0. So my domain is 0 to positive infinity, because only these values are valid. My range, also, I'm going from 0 up little by little, so my range is also 0 to positive infinity. F of x equals a cube root. Do I have a restriction there? No. Is that a square root or a cube root? Let me show you why there's no restrictions for cube roots. The cube root of 8 is 2. But the cube root of negative 8 is negative 2. It's valid. Because what's negative 2 times negative 2 times negative 2? Negative 8. So cube roots do not have restrictions, hence why the domain is all real numbers. Little by little, I'm going to be going to the right forever. Little by little, I'm going to be going to the left forever. Also, my range. From 0, I go up. From 0, I go down. And 0 is included. So all real numbers for my range. Is making sense, guys? Linear function. Linear function, I should have written the equation, huh? This is f of x equals x, come on, Moro, mx plus b. That's my linear function. By the way, you guys remember linear functions, right? Because that's what 8.5 is. You're going to have to do that on your own. It's pretty simple. So in this case, it's linear. Do I have any restrictions there? So domain is going to be all real numbers. And I'm going up and down forever. So range is all real numbers. Constant function. Constant function, this is a y equals a equation, where a is the point that it's going through. Remember, this is when the slope is 0. It's going right through here, so this equation would be y equals 3. You guys remember that? This is a constant function. My domain, it goes to the left and right forever. There's no restrictions. So I got a domain forever equals negative infinity to positive infinity, all real numbers. Now the range. Isn't there only one particular y value that's valid here? So the range is a, or the point a, or f of x, which is y, equals a. Either way you want it. The range is just that one point. It does not go up or down from here. It stays here forever. So my range, my only valid range value is that particular a that is graphed. Does that make sense? Last but not least, absolute value function. Absolute value function is f of x equals absolute value of x. There are no restrictions here. So my domain, as you can see, it goes little and little to the right, little by little to the left. No restrictions. Domain is all real numbers. My range, though, I go from 0, and then I go up. Okay? So my range is 0 to positive infinity. Pretty easy, right? Yes, sir. If I have an undefined, then it's not a function. Right? He's asking, what if it's an x equals equation, which is a vertical line? Then it's not a function. These are all libraries of functions. Thank you, sir. Does that make sense? All right, let's move on. Now, all of this, I went way further in detail because I like to make sure you got everything you need. The book, by the way, did not go over the restrictions that I went over. It only went over the first restriction. But you better believe that I'm going to quiz you on all 3 restrictions. We'll practice today because we got plenty of time. But right now, this is basically what they wanted you to get from this section. They wanted you to be able to obtain everything that I have here from this particular graph. So let's check it out. Find f of negative 2. Remember, this is function f. This whole thing is function f. Okay, this is f of x, where x is independent. What did I plug into my x? Negative 2, right? So by looking at the graph, my friends, when x is negative 2, what is the y value that attaches to that? So what is the value of f of negative 2? 3. What does that mean, more? That means that when x is negative 2, my f of x is 3. Is that making sense? Oh, you guys got it? Okay. F of 0. When x is 0, where does it go? What's my y? 3. So find f of 0. When x is 0, f of 0 is 3. You with me? Is f of 4 positive or negative? Okay. Go to when x is 4. When x is 4, it's over here, right? So I go down, and it attaches to a negative y value, correct? So that's negative. Now, for what numbers of x is f of x 0? Remember that f of x equals y. So at what x does y, or f of x, equals 0? 3 and negative 4. Excellent. So when x is negative 4 or positive 3. When they tell you stuff like, find the x when f of x is blank, they're giving you the y value. They want you to find the x value that's attached to that y value. Guys, I need this to be really, really good for you, because sometimes people think they got this and it goes over their head and then they do miserably. You guys are with me so far? Thank you. What is the domain? Okay, what's the domain here? What's the domain? Is it going to the left little by little? And it's going to the right little by little, correct? So it's going to be all real numbers. Negative infinity to positive infinity. Very good. What is the range? Thank you. Negative infinity, because you always go small to large, to positive 3. Excellent, son. Well done. Okay, what are the intercepts? Remember, there are my x-intercepts, which is the x value when y is 0, and there's my y-intercept, which is the y value when x is 0. So what are my intercepts here? Yes, sir. Come again? The 3 is in a bracket here. Yes. Thank you, sir. What are the intercepts? Yes, sir. Okay, so my x-intercepts, I got two x-intercepts. Well done. Negative 4, 0, and, hold on, 3, 0. Okay? And then what's my y-intercept? Right here, 0, 3. Very awesome. Those are my intercepts. Beautiful. And then for what numbers of x is f of x negative 2? So I'm telling you that f of x equals negative 2. In other words, y equals negative 2. What's the x value that's attached to a y value of negative 2? 4. Very good. When x is 4, that point right there, no, that's negative 4. Well, it's actually both. Negative 4, 2, negative 2, and also right here, 4, negative 2. So for what values of x? X can be 4 or negative 4 or negative 4, and I will get my y value of negative 2. Talk to me, brother. Okay. I want to know what x values give me an f of x of negative 2, right? Remember that f of x is y, correct? Right? This is the negative 2 here, right? So if I go like this, what x value is attached to that? 4. Isn't that 4 negative 2? Okay, negative 2 over here. What x value is attached to that? 1, 2, 3, 4. Oh, 5. I'm sorry. It's negative 5. Negative 2. So it's negative 5. My bad. So when x is 4, my y is negative 2. When x is negative 5, my y is negative 2. Does that make sense? Talk to me, brother.
Why is there a bracket on the
Because there's a bracket on the 3. What is the range of f? Because 3 is valid. This is a solid line. So it is valid. Thank you, sir. Does that make sense, my friends? All right. Thank you very much. Hope you learned a lot. We'll practice now.